Hello everyone. In several of my recent Python videos, we've been using strings for various purposes. For example, several videos ago, we were using the built-in input function in order to prompt the user for a number. Well, input returns a string, and we were wanting to store that string as its numeric equivalent so that we could do arithmetic with that number. So we saw how we could convert a string to, say, an int type using the built-in int function. We also saw how we could iterate over strings because strings are sequences of characters using a for loop. And then more recently, we saw some relationships between strings and lists. So they're both sequences. Strings are sequences of characters. Lists are sequences of really any type, including mixed type. So for example, what I have up here on my screen includes a demonstration of the string method join, the built-in list function, and also the string method split, which returns a list. So take a look at those previous videos for some introductions to strings. What I'd like to do in this video is essentially add a section to my main.py file that I've been building up in list fun over a few videos called More on Strings. More on Strings. So recall, a string is a sequence of characters. We'll need a sequence of characters stored in a variable, a string type variable, for this demonstration. I like keeping with the candy theme that I've been working with in list fun, but Twix is a little bit of a kind of too short string for us to work with for this demonstration. So I'm going to grab a longer one. I'm going to grab starburst. So I'm going to have a variable called word, and it's going to store the string starburst. So I'll print out word just to make sure that was in fact saved. Okay, so far, so good. So a little bit of review of strings here. So strings are a sequence of characters that support zero-based indexing. So for example, if I print out word sub 0, I'm going to see the S, the first S right here. If I print out, say, word sub -1, they support negative indexing just like lists. I'm going to see the T, the last T on the end, and they also support slicing. So let's say I wanted to get tar, T-A-R. Well, that starts at index position 1, and it ends on index position 3, so I'd have to go one further because the ending index is exclusive. So this should print out S, T, and tar. And there we see S, T, and tar. Now, let's take some notes on the immutability of strings. Immutable means they can't be changed. So with lists, for example, lists are mutable. We're able to change lists. For example, right here on line 22, I overwrote the first element in list of numbers, which was 0, with hello. Lists are mutable. They can be changed. On the other hand, strings are immutable, which means they cannot be changed. Why don't I try doing the same thing that I just showed you with a list, but with a string? So for example, I'm going to try and overwrite word sub 0 with, say, capital S, because let's say I no longer want starburst to be all lowercase. I want it to be title case. If I try and run this, it's actually going to crash because there's a type error. Str, which is the type for string, object does not support item assignment. And that's exactly what I'm trying to do here. I'm trying to assign to an item of a string object. Because strings are immutable, this actually crashes the code. So strings are immutable, meaning they cannot be changed. Next, let's take a look at some handy string operators. We'll start with string concatenation. That's the plus sign that you're familiar with from, say, arithmetic, aka binary addition. So for example, if I were to add 3 plus 4 and they were both integers, then I'd get 7. But let's say I want to add to word plus, say, some exclamation marks on the end. Since both the operands of this plus sign here are strings, this is not binary addition. Arithmetic does not occur here. This is instead string concatenation. And what happens is the string stored in word, which is starburst, is jammed against the string on the right side, the right operand, which is the 2 exclamation marks. So essentially, They're just butted together in the same order at which I've declared them as a left operand and a right operand. So let's print this word out so we can see what changed. So there we go. So left operand butted right next to the right operand. We also have string repetition. So that's the asterisk that we think of arithmetic, we think of binary multiplication. Well, let's say I print out word times 5, then I'm actually going to get the string and word repeated 5 times. And there it is, starburst, exclamation mark, 5 times. 1, 2, 3, 4, 5. Some additional string operators to talk about include string comparison operators. For example, I can compare if two strings are less than, so one is less than the other, less than or equal to, greater than or equal to, or not equal to. So we read this exclamation mark here as not. So let's see an example of this. Let's say I print out is starburst less than, say, apple. So this is going to print out false. Starburst is not less than apple. I'll explain why here in a moment. Let's say I flip these. And by the way, I could use, instead of starburst the string, I could use starburst stored in Word. It just has exclamation marks on the end, so I just don't want to introduce anything too confusing at this point until I explain how strings are compared. Okay, so if I flip these, apple less than starburst, then I'm going to get true this time. Now let's say I do is starburst in all lowercase less than starburst in uppercase. So this prints out false. Interestingly enough, you're like, well, they both store starburst, so why would this one be not less than this one? Like, why would this one come before this one if you were trying to order these two strings? So let's take this down a level of complexity and let's just look at, say, ABC. So let's start with A less than A. So this is going to print out false. A is not less than A because these are actually the same strings. So let's say I replace this with equality. So this is going to return true because the string A does equal the string A. So when I just had strictly less than, since these are equal to each other, then one is not strictly less than the other. But if I do less than or equal to, then my last two prints down here will both be true. So true, true. All right, now let's try doing something like ABC. Is ABC equal to, say, AB? These are not the same strings. This one has a C on the end. This one does not have a C on the end, so this returns false. What about is ABC less than AB? So this prints out false, interestingly enough. And now let's do one more little demo here. Let's do is ABC less than, say, ABC in all caps. We get false. So some of these are straightforward, like you're like, okay, the string A equals the string A, that's true, but like, why is ABC less than AB false? Or why is ABC less than all caps ABC false? So let's provide a little bit of context for understanding how these string comparisons are working. Strings are compared character by character from left to right, or more generally, compared in the order at which the language is written. So English, for example, is a left to right language, so then character by character is compared left to right. Okay, so they're not compared actually based on their characters in the string. They're compared based on what are known as their Ascii or their Unicode values. So these values are integers that represent characters. And the characters that are used to represent, say, lowercase a or uppercase a are standard. In fact, you can go look them up. So what I've done is a quick Google search for Ascii Table, and I've clicked on the result here from Wikipedia, and I've got what's called the Ascii Table showing up here. So the Ascii Table shows these decimal values for common characters. For example, if we look in this kind of middle column here under char, here's the capital letter A, and if I go over in its row to decimal, the capital letter A is actually mapped to the decimal integer value 65. Now, if I keep scrolling over a little bit, here's lowercase a. If I look in its row, its decimal value is 97. So the capital letters have lower decimal values, lower ASCII values, than the lowercase letters. So that's why when there's a comparison of, say, lowercase a to uppercase a, remember character by character, left to right, well, lowercase a is 97, uppercase a is 65. Is 97 less than 65? No, false. No more comparisons of characters need to be performed. Same thing with starburst up here. So let's look up what lowercase s is. So lowercase s is ASCII value 115. Uppercase s, I'll scroll down a little bit here, is 83. So this is asking, is 115 less than 83? No, it's not. And that's why we got the false up here. So a key takeaway here, in addition to knowing that strings are compared left to right based on ASCII values, is that comparisons are case sensitive, right? ABC less than ABC, even though these have the same contents and how we think of the letters, the alphabet, they're different case. So they have different ASCII values, and therefore you're going to get a result that is case sensitive. Now, there are methods that you can call on strings to convert case. For example, let's say I take this last print statement here, and I call .lower on ABC in all caps. Then I'd be comparing ABC to ABC, and let's do an equality here. And I'll get true because ABC in lowercase is lowercase ABC, which is the same string as the left operand here, lowercase ABC. So let's explain one more of these print statement outputs here. Let's do this false here. So 1, 2, 3, line 116. So remember, we compare character by character from left to right. So is the ASCII value for A equal to the ASCII value for A? Yes. We move on to the next character. Is the ASCII value for B equal to the ASCII value for B? Yes. And then is the ASCII value for C less than, oh, there isn't another character here. So we return false because we've run out of characters to compare, right? This string has more characters than this string, so it is not going to be less than this smaller string here. All right, keeping this in mind, the ASCII values in this case-sensitive comparison is actually how sorting, say, a list of strings works. So let's say, for example, I have a list of words. I'll do maybe do Twix, Starburst. Let's do our word, which stores Starburst with some exclamation marks. Let's do Starburst in all caps. Let's do Reese's and Snickers. How's that? So let's say I print out the list of words in sorted order. So I'll use that built-in function sorted. So this is going to do a case-sensitive sort of this list of strings. So capital S, this is the only capital letter. So we know all the capital letters in the ASCII table come before the lowercase letters. So it is now first. R comes before S. Now we have two S's, so we move on to the next character. So N comes before T. Okay. Now we're looking at Starburst and Starburst. So these are the same for the first 1, 2, 3, 4, 5, 6, 7, 8, 9 characters. But then this string has additional characters. So it's longer, it has more characters. So it's going to come after Starburst without the exclamation marks. And then here, lowercase t comes after lowercase s. So hopefully that sheds a little bit of light on how strings are compared. And if you're ever doing kind of a sorting routine or you're doing some kind of ordering of strings, just keep in mind that you probably want to convert all of your strings to say lowercase with dot lower or uppercase with dot upper before you do the sort if you want a case insensitive sort. I'll wrap up this section here on string comparison with a little emphasis on what from the Ascii table should you know at a minimum. And I always encourage new programmers to just remember that capital A has ASCII value 65 and lowercase a has ASCII value 97. There are perhaps other ASCII values that you may work with on a regular basis that you should remember for your particular project or job, but in general for aspiring computer scientists, data science, software engineers, etc., just knowing these two I think is a good start because that way you can interpret results like we saw here with the string comparison. So capital A, 65, lowercase a, 97. Try to either commit those to your memory or work with string sorting and ASCII values enough that you use them enough, they stick to your memory. All right, let's take a look at some other string methods. So for example, we already saw lower. There's also an upper. There's also join, which I showed a demo of join in a previous list video up here. Join. There's also split, which I showed in a previous video as well. Join can be used to essentially stitch together a list of strings into a single string, and then split can be used to take a single string and split it into individual strings that are stored and returned in a list. So I'll just write those here. So we've got lower, upper, join, split. I'd like to do a demo of strip and find in this video because these are two incredibly handy string methods as well. So let's start with strip. So strip removes leading and trailing whitespace characters. So when I say whitespace characters, what I'm referring to includes spaces, like blanks, new lines, and tabs. Those are the most common whitespace characters you'll probably encounter. So I'm going to create Word again, and I am going to have starburst as my text in the string, kind of the content that I'm interested in storing as the word. But I'm going to preface starburst with a bunch of spaces and new line characters and tabs. I mean, this is just truly random stuff I'm putting in here. And then I'm going to put a suffix on this starburst text here with the same thing, like a bunch of tabs, new lines, spaces, whatever, just a bunch of garbage, so to speak. I'll print this out so you can see how it's rendered in our terminal output here. Here it is. Starburst kind of end up nicely in the middle here. But all of this right here is from line 128 string declaration. And if you're interested, if you ever want to see kind of a raw representation of a string, there's a built-in function called REPR. It says return the string representation of the object. And if I pass in word, then I'll be able to actually see those characters instead of see how they're rendered in the terminal. So here's the ending single quote for the string. Here's the beginning single quote from the string. And REPR allows us to see the true kind of raw string representation, not how that string is rendered in the terminal. So that's kind of handy to know about for debugging purposes if you're ever like, what's going on here? Why is this not lining up? Or why is this indented? Or why is this on its own line? And it can be difficult to find out just by looking at the terminal output. So keep this in mind, REPR, get your raw string representation. All right, so now it's time for seeing strip in action. So here's what I'm going to do. I'm going to print out word.strip. So what strip's going to do is it's going to return a copy of the string, because remember, strings are immutable, so it can't actually do an in-place strip, with leading and trailing white space removed. So I'll do this one more time using REPR just so that you can see truly all of those white space characters that I put on line 128 when I declared word are gone. So we don't see a bunch of spaces before above, before, after, and below starburst, and then here's that string representation where we can see all the characters in the string, and they're gone. Also point out that there's an L strip and an R strip, so if you just need to strip off leading whitespace characters or trailing whitespace characters, you can look into L strip for left and R strip for right. Next, let's do a demo of find. So I'm going to take word back to its original form, just starburst, and let's say I want to find the starting index of a substring. So for example, we saw earlier that tar is inside of starburst when we were doing that string slicing. So let's say I want to find out if tar is in word, and if it is, where does it start? So I'll do print word.find, and I'll pass in tar. While I have the documentation preview up here, let's take a look. So you can see that the notation for calling find, since it's a method, is s.find. And then we have a few options for what we can pass in for our arguments. So at a minimum, we have to pass in sub, which is the substring. It's going to return an int. So it says return the lowest index in S, which is the string that we're calling find on, where substring sub, which will be our argument, is found. So let's try it out. So S is at index position 0. The T of the first instance of tar is at index position 1. So that's why we see 1 printed out here, because the substring tar starts at index position 1. Now let's say I pass in a substring that isn't in the string, like hello, for example. Then find is going to return -1 to denote that this substring was not found, and that's what the documentation says at the bottom. Return -1 on failure. So this is important because -1 could be a valid index, so this is a non-empty string, right? We know that strings support negative indexing, so you wouldn't want to just use the return value from find without checking to make sure that it's not equal to -1 first. So for example, let's say I'm going to assign to index word.find. Let's do just the B this time. So before I use index, what I want to do is check, make sure index is not equal to -1 before I print out something like B was found at, and then use index. And then let's say I just do words of index just to use it. So there it is. B was found at 4. Then I index at index 4 to get B. There are several other incredibly useful string methods that I encourage you to take a look at in the documentation, such as capitalize, count, is alpha, is digit, is upper, all sorts of really, really great methods. These are just a few commonly used methods, but they're by no means all of the methods. So please, please, please take a look at the Python documentation and read about some additional string methods that can help you when working with strings in Python. Thanks for watching, and subscribe to my channel for additional Python tutorial videos.